So for 33, we're going to get some more experience doing some graphs, coming up with functions, and this really just builds off of what we did in 32. So for this one, I would select, since it's starting at 0, 0, I would select a sine function. It has a amplitude of 0.5. It goes from here to here, negative 0.5 to 0.5. So I would say my amplitude is 0.5. Starting at 0 going up, so again, I'll use a sine, 0.5 sine. And then now I need to figure out, so it starts here, goes up, and then come here. It's got a period of pi, 1/2 pi, or period is pi over 2. And remember, the period is equal to 2 pi over b. You'd also say that b is equal to 2 pi over the period, which is where I get to, but I just remember it this way, multiply by b, and then divide by pi over 2, or multiply by the reciprocal. So that gives us that, in this case, b is equal to 2 pi times 2 over pi, right? The reciprocal of pi over 2. Pi's will cancel, and you get 2 times 2 is 4. So b is equal to 4. So then that's just going to be 4 x. There has not been a horizontal shift nor a vertical shift. So this is our function. I'll just put y equals, you could do f of x, I guess. So that's that function, that's that graph. For b, I see an amplitude of 2, right, negative 2 to 2. I see this as a cosine because it's starting, in this case, low, but it's a negative cosine because I've got to flip this over. That's one way to do it. If I multiply by negative, this goes up here and this comes down here. So this is going to be 2 cosine minus 2 cosine. Then I need to figure out what the period is. So it's going to repeat here. The period is 1. So 1 equals 2 pi over b. Right? Starts here, starts to repeat here. Multiply both sides by b. So we get b equals 2 pi. So that's minus 2 cosine 2 pi x. And as you'll see in the answer key, there's multiple correct ways to write these. Do it with a shift. I've got the third way. So either way, multiple ways. You could do this as a shifted cosine. You'd even do it as a shifted sine if you wanted to. Now this C part, what we hopefully you can see, it's not completely symmetrical. It kind of looks like they've changed a little bit, but it's going from negative 4 up to 2, so it's been shifted down by 1, because think about it, if I moved it up to negative 3, then the top would get moved up to positive 3, right? So one thing that's very evident to me is a shift. It was shifted down, a vertical shift down of 1. So we're going to need to subtract 1. So d equals negative 1. I have to subtract 1 at the end. Again, just like the last one, it's starting down low. So I'm going to do this as a cosine, and I'm going to do it as a negative cosine because cosine typically starts high. So I'm going to write this function as negative cosine. What would be the amplitude? Well, amplitude, you could say, is going to be from 2 subtract negative 4 all over 2. So it's halfway between the top and bottom of the wave. Um, that's 6 divided by 2, which is 3. 3 is our amplitude, which is the number in front. So we're going to go with the minus 3 cosine. We're going to have to subtract 1 on the end, but we haven't got there yet. So I don't need to shift it because I'm doing this. I'm starting sort of the standard place we're supposed to start. But let's see, where would be the period? So here's the repeating part, right? From here to here, it starts to repeat. Our period is pi. So pi is equal to 2 pi over b. Multiply both sides by b, and then divide by pi. So we get b, multiply both sides by b, that goes away. B over pi equals 2 pi, and then divide both sides by pi. So what we see is b is going to be equal to 2. So inside here, I need a 2x, no horizontal shift, but a minus 1. So that would be my function that I would use for this one. I think this is the last one we need to do. And again, I see right away, this goes up to 5, right? And down here, down to negative 3. So there's been a shift because those numbers should be the same, the symmetric. So how far has it been shifted? Well, if I shift it down 1, this would be at 4. And the bottom, if I shift it down, would be at negative 4. That would be sort of in the regular position. So what I can see is it's been shifted up by 1. So I'm going to say I'm going to add on the back side a plus 1. D is plus 1. This one's a little harder. Okay, so if it's been shifted up 1, see this would be at 0, 0, so then that would be a sine function, a standard sine function that's been shifted up 1. Okay, so that makes that a little easier. So it's a sine function, no horizontal shift, just a vertical shift. Amplitude is going to be 4, right? You could do it as 5 minus negative 3 divided by 2, so the top of the wave to the bottom of the wave, halfway there, is going to be 5. That gives you 8 over 2, which is 4. Right, so that's your amplitude. And it's starting sort of at 0. If we shift it down, it would have started at 0, gone up, so it's positive. Then the last thing we just need to see is where's what is the period. So if I go from here, up, down, up, this is going to be the period is going to be pi over 4. If you didn't quite see that, you can see, well, here's 1 pi, and then here's 5 pi. So that the distance between that is 4 pi. So the period is 4 pi. Can I just remember that's going to be equal to 2 pi over b. So you could maybe see that b has to be a half, but if not, we'll go ahead and do the multiplying b, cancel, cancel, and then we divide by 4 pi on both sides. So b equals 2 pi divided by 4 pi. Pi's cancel. 2 divided by 2 over 4 gives us 1/2. So that's the value that goes in front of the input. So 1/2 x. No horizontal shift, but there was a vertical shift of 1. So that would give us our value there. Again, it's not the only way to do it. You could do it as a cosine that's been shifted by a pi. That works, but this is a valid one as well. And again, we could always, one strategy when you're on the test and you're asked to do this, another way to do it is, especially with multiple choice, you could actually graph these and see if that's what you end up with. So for sine, oops, we already got one of those. So I'll do 0.5 instead of 1/2, right? X plus 1. Now, I also like to, so to match this up, I kind of try to match the window. So I'm going to do like, when I go for my window, I'm going to have my X at minus pi over 2, pi over 2, no, minus pi over 2, back it up, divided by 2. There we go. It'll figure it out. Gives us a number. And then this looks like it goes to about 6 pi. So X max going to 6 pi. The scale is in pi over 2, which is kind of cool because we did the trig thing. And then the Y is going from, say, -4 to -8. So Y is -4, or not -4 to +8. And so then our graph should look very much like this one as far as size and everything else. I'll let it draw. It keeps on drawing. We see it's pretty doggone close. Now we don't have our markers here, but this is pi over 2. This is 1 pi. That's looking good. 1 pi, 2 pi, 3 pi, 4 pi is here. Okay, 5 pi would be there. It's been shifted up, so you could, so you can always do a check, and I highly recommend doing that. So that brings us to the end of the review questions. Take a look at these, prepare yourself well, and we'll see you on Monday.